Students, all of you, good evening. Welcome to the session. Continuation of chapter 1, that is Fundamentals of Electrical Circuits. I'm starting lecture 18. This is the final session with respect to chapter 1. After this session, we'll start the chapter 2, that is AC analysis. In this session also, mainly you have to see some practice questions and one of the concept of equipotential concept and exact concept of I'll be given source transformation. We'll see what is the importance of that source transformation also. With that, concepts will be complete. Can anybody answer these questions, friends? These models are framed in GATE exam. Is a previous GATE question. In the network shown in figure A, X and Y are two practical sources whose VI characteristics are plotted in figure. Determine the current I in 1 ohm resistor. You have to find what is the current in 1 ohm resistor. There is two sources are given, source X and source Y. This source X characteristics, IV characteristics are given like this, and source Y IV characteristics are given like this. First, I am solving for source X, that is source X. For source X, you see the coordinates. This is 4, 0, and this is 0, 2. For source X, voltage is 4, 0. Voltage 4 volts, current 0, then it indicates open circuit. And current access is given 0, 2. That is voltage 0, current is 2 amperes. This is short circuit. No need to draw the equivalent circuits, all these. Simply remember like this. This is Vx, let us assume that this is Vx for source X, and this is the current Ix. Then what the resistance offered for source X, Rx equal to is Vx by Ix. Voltage is 4 volts, current is 2 amperes. That is 4 by 2. This is equal to 2 ohms. With respect to source X, we calculated. For source X, the resistance of source X is 2 ohms. Similarly, you try for source Y. Come on, do it. So try for source Y students. Yes. Now for source Y, this is Y axis 0, 3, X axis 3, 0. That is for source Y. Source Y. By drawing the equivalent circuits, all this also, we can solve this one, but not required. Simply you can do like this. Source Y, that what the voltage? Voltage is 3, 0. That is, you have to take this is Vy. But the current supplied by source Y, 0, 3. Then corresponding to source Y, calculate the source Y resistance, Ry equal to Vy by Iy. That is 3 by, voltage is 3, current is 3 amperes, 3 by 3. This is equal to 1 ohm. This is equal to 1. Is it correct? Is equal to 1 ohm. Now, I am representing this equivalent circuit. This source X voltage is this one. Source X voltage is how much, friends? This is 4 volts. Whose resistance is? Source X resistance is 2 ohms. Next, source Y resistance is 1 ohm. This is 1 ohm. Source Y voltage is how much, friends? Source Y voltage. This is 3 volts. And this is connected to 1 ohm resistor. That is given in the circuit. This 1 ohm resistance. You have to find out what the current to I. Then what is I equal to? The total minus plus aiding. These are similar polarity, aiding polarity, like this. This is aiding polarity. Minus plus 7 volts. 7 by what the total resistance? 1 plus 2, 3, 3 plus 1, 4. 7 by 4 amperes. The current in the circuit equal to, that is 7 by 4 amperes. This is the final answer. Then what is the answer for this question? Answer is, that is 7 by 4 amperes. Clear, students? From the given access characteristics, IV characteristics, for source X, what is the voltage, what is the current? For source Y, what is the voltage, what is the current? Once you know the voltage and current, what is the resistance offered by the source X? 2 ohms. Resistance offered by the source Y is 1 ohm. Then this is internal resistances of the sources. You have to find the current through 1 ohm resistance. Then I equal to 3 plus 4, 7. 1 ohm, 2 ohm, 3 ohm, 3 ohm plus 1 ohm, 4 ohm. This is equal to 7 by 4 amperes. Clear? Okay. Any doubt? Is it okay? This model, this is previous gate question. Can anybody answer this? VI characteristics of figure A is plotted in figure B. Then determine the current I in RL. if RL equal to 10 ohms. If RL equal to 10 ohms. Come on, students. This axis you see, this is current axis. This minus 2 comma 0. Minus 2 comma 0. Okay, that is minus 2 comma 0. Next, what is the voltage? 0 comma minus 20. Then corresponding to this Vs, this is current axis na Is. This is Vs, voltage axis na Vs. This indicates which condition? Voltage 0, sorry, current 0, voltage exists. Current 0, voltage exists, open circuit condition. This indicates which condition? Current exists, voltage 0, short circuit condition. You have to take one time, you can open circuit it, short circuit it, then you can find that one. Or directly Vs you know, Is you know, then what is the Rs you have to calculate, friends? Rs equal to Vs by Is. Vs is minus 20, Is is minus 2, this is equal to 10 volts. This is voltage access, friends. That's why it is giving the voltage. This is current access, that's why it is giving the current. That point to remember. Once you know the Rs, then you have to find what the current is. This Rs equal to, this is Vs. Vs how much you got? This is Vs equal to how much? This is minus 20. Vs equal to minus 20 volts. Then Rs equal to how much? Rs equal to 10 ohms. RL it is given, how much it is given? 10 ohms. Is equal to 10 ohms. Then you have to find the, what is the I? This I equal to, find I equal to minus 20 by 10 plus 10. This is equal to minus 1 ampere. This is the calculation. I equal to minus 1 ampere. Clear? Yes. See the one more question. Can you answer this? If RL equal to 4 ohms, find Rs and I. How to find Rs and I? This is voltage axis. On y-axis 0 comma 20. This is Vs. And this is the current axis. On x-axis minus 10 comma 0. This is Is. Then you have to find what is Rs equal. This Rs equal to 20 by minus 10. If you take minus 2 ohms, this is wrong. Why? The resistance never be negative. The resistance never be negative, sir. Resistance is, I told already. Resistance values are always positive, never be negative. But I'm getting minus 2. This is wrong. But you see this one here, even though it is this is I is minus 10 amperes, but this Is and I is opposite. Actually, this is I and Is is opposite. That's why this is I, but Is and I is opposite now. This is Is and this is I, opposite. That's why you have to take what is Is equal to. It's a minus of minus 10. This is equal to 10 ampere. Now you have to substitute. This is 10 steps. Then 20 by 10, this is equal to how much? 2 ohms. Is equal to 2 ohms. Okay. Now you have to calculate this I value. Then I equal to Vs by Rs plus RL. Vs is how much? 20. Rs is how much? 2. RL is how much? 4. Clear? 20 by 2 plus 4. 20 by 2 plus 4. How much you get? 20 by 6 amperes. This is, you have to take 10 by 3 amperes. 3.33 amperes. 3.33 amperes. But this current is, you calculated, na? This current is opposite to this one. This current is opposite to this one. Actually, let us assume that this is IL. Let this is the IL. This is IL I calculating. But you have to calculate this I. This IL and I is opposite. Na? This I is this direction. I calculated IL is this direction. Then what is I equal to? Minus 3.33. That is right answer. I equal to minus 3. See, this current direction you see, but in the previous problems, the direction of current is always into the load. In the previous problems, the current direction is always into the load. This concept I'm not consider here. Whatever the concept I explained here, why you have to take opposite, because the current direction is given out of the load. Clear, sir? That's why actually it is a minus 10, but I taken plus 10 because current direction is opposite. Actually, here 3.33 amperes load current I got, but this load current and this are opposite. Question is asked not IL. Question is asked IA. That's why I calculated this minus 3.33 amperes. Clear, sir? That you have to concentrate this type of cards. Let us see the next one. Determine relation between V1 and V2. Can anybody answer this question? I think this model I already solved. Once again, I'm solving. But here we can get one important observations. How to one important observation, one important concept you can get from this problem. That's once again. There is so many ways of solving these problems. You have to find what the relation between V1 and V2. Not same problem, same model I already solved. What is the relation between V1 and V2? Yes. Here I'm solving 3 or 4 different ways. I'm solving this problem. 3 or 4 different ways. Say for example, this let's assume that this is the reference node. This is the reference. This is zero potential. If it is a reference node, you know this 2 amperes of current is flowing here. 2 amperes of current is flowing through 1 ohm resistance plus minus 2 volts. Plus minus 2 volts. If you assume this is the reference node, that is a zero potential. What is V1? You tell, no need to apply KVL. Directly you tell me what is V1. Come on, what is V1? This from this point to ground. From this point to ground, 2 volts is present. That's why V1 equal to 2 volts. Can anybody tell what is V2, sir? V2 equal to, from this point to ground, how much voltage is present? 2 volts. V2 is also 2 volts. Then what is the relation between V1 and V2? V1 minus V2 equal to 0. Then V1 equal to V2. This is the relation between V1 and V2. Clear? I taken this is ground. Directly tell the answer. This is V1 switch. This is V1. This is 2 volts is there. And this is connected to ground potential. This is V1. What is V1? V1 equal to 2 volts only. That only written. Here also same. This is plus minus 1 ohm resistor. This is 2 volts. We got. This is V2. And it is connected to ground. Then what is V2? V2 is also 2 volts only. That only written here. Then V1 minus V2 equal to 0. Then V1 equal to V2. Oh. Same problem. I will solve like this. See the one same problem. The another method I am solving. See for example, if you take this is the ground. Instead of assuming this is the ground, I am assuming this is the ground. I told already, any one node is taken as a reference. Now it is a 0 volts. Now come on students. What is V1 you tell me? What is V1? What is V1? What is V1 sir? Come on. Between V1 and ground, how much voltage is connected? 5 volts. V1 equal to 5 volts. V1 equal to 5 volts. Now apply, this is the voltage source. Voltage source means it's connected like this. It's connected like this. This is a source. And apply KVL in this loop. Apply KVL in this loop. Negative to positive, positive. V2. Negative to positive, positive. This is how much? 2 volts now. Already 2 amperes of current is flowing here. 2 volts. Negative to, sorry, positive to negative, negative, minus 2. Negative to positive, positive, plus 2. Positive to negative, negative, minus 5 equal to 0. Then what is V2 equal to? Minus 2 plus 2 cancel. V2 equal to 5 volts. Then also we are getting relation is V1 equal to V2 now. Final relation I am asking. V1 equal to V2. Then what is V1 minus V2? V1 minus V2 equal to 0. Here also what is V1 minus V2? V1 equal to V2. Here also V1 equal to V2. That is V1 minus V2 equal to 0. Clear? Like this also you have to answer. Same problem I will solve like this also. Between these two sources I am applying the KVL. Between these two sources. This is one source. The source is connected like this now. Between these two sources I am applying KVL. Between these two sources I am applying KVL. This is how much? Plus minus 2 volts already you know. Because of 2 amperes of current is flowing 2 volts. Between these two sources I am applying KVL. These are sources. I am not taking reference node. This is the two sources. I am applying KVL. Negative to positive. Positive. V2. Positive to negative. Minus 2. Negative to positive. Plus 2. Positive to negative. Negative. Minus V1 equal to 0. Minus 2 plus 2 cancel. Then what is V2 equal to V? That is V1 minus V2 equal to 0. I am getting same relation or not? I am getting same relation or not? Clear, sir? Same relation or not? See, there is a different ways of solving the same problem. Same problem. If any, that's why I'm telling that if you have to get the more confidence in the network theory, mainly in the fundamentals, you have to practice more and more. You can get any idea to solve the problem. But avoid the misconception. Avoid the misconception. That is important. See, for example, Some students will think like this, sir, I will take this is the node, these two are the ground potential. These are the ground, that is reference nodes. If you take these two are the reference nodes, can you tell what is V1 equal to? 5 volts. Can you tell what is V2 equal to? This is 2 amperes of current, 2 amperes of current. This is plus minus 2 volts. 2 into 1 ohm, 2 volts. That is 2 volts. What is V1 is not equal to V2? Then this is misconception. Wrong assumption, this one. Why? You don't assume two reference voltages. You don't assume two ground potentials. You don't have any two ground potentials at a time. You have only one ground. But don't think, sir, but you taken two ground potential here, sir. These are not taken ground potentials. These are the voltage sources. These are source voltages. Applied KVL here. But don't take two ground potentials. For single network, at a time, you have, at a time, don't consider that. But individually take any ground potential. That is correct. Okay, this is the misconception. Clear, students? Okay, this to explain this concept only, I taken once again this problem. Clear? That you have to concentrate. Then this also one important model, okay, that you have to check it. You have to find the what is I1, I2, and I3. But some data is missing here. This I am drawing. This is the given data. This is 100 ohms. 100 ohms. This is connected here. And this current is I4. And this current direction is I2. And this current direction is I1. This current direction is I3. Then you have to find I1, I2, I3, I4 students. Now see, let this node is A, this node is B, and this node is C, and this node is D, this node is E. You have to take this is E, and this is F. Yeah. What is the observation here, friends? What is the observation here? A to C, C to E is connected through one wire only. These are common. A, C, E nodes are the common because these are connected with one wire only. I told already. If it is connected with one wire, that taken as a one node. B, D, B to D, D to F. It is connected with one wire only. That is one node only. Then I am taking like this. AC is joined. I am taking like this. Just to simplify this, this is the procedure you follow. This is A, this is C, and this is E. A, C, E nodes are joined. A, C, E nodes are joined. Single wire. Next, B, D, F. B, D, F nodes also joined. B, D, F. Let this is B. Let this is the D. This is F. This B, D, F nodes are joined. B, D, F nodes are joined. This is single wire. Now see, between A and B, how much resistance is connected? 25 ohms. This is 25 ohms is connected. Then between C and B, that is between B and C, current source is connected, but current source direction is between B and C, but current source direction is B to C. Current source direction is B to C. But all the nodes are same. All the nodes are same, sir. This is same node. B, D, F, all are same. You connect here, connect any at any point you have to connect. That is remains same. But current direction you see, the current is flowing B to C. Don't think you have to connect here only. You connect here at any point. This is totally same wire. That is the same wire. But current direction you have to see. The current is flowing from B to C. How much? 0.2 V. B to C current is flowing. That is 0.2 V. Next. The next one is between C and D, 10 ohm resistance is connected. Between C and D, 10 ohm resistance is connected. This point is also B. And this point is also C. All are same. B to C. Between C and D, 10 ohm resistance is connected. Between C and D is 10 ohm resistance is connected. Next. Between D and E, 25 amperes of current. But current direction is E to D. This is D and E. Current direction is E to D. This is 25 amperes. Then finally, between E and F, 100 ohm resistance is connected. 100 ohm resistance is connected. Okay, this is the equivalent circuit, students. Given circuit, I draw like this. Now it is very easy to solve. I1 is between A and C. A to C is I1. You have to find I1. Next, I2 is which direction they given? B to D. I2 is what the I2 current direction is? B to D. I2 is B to D. Next, I3 direction is C to E. I3 direction is C to E. I3 direction is C to E. Next, I4 direction is F to D. I4 direction. What is the I4 direction? It is given. F to D. F to D. This is E and F now. This E and F. That is F to D. I4 direction is, that is a F to D. This 25 amperes of current is between E and D. This is E. All are same points. This is E and this is D. E and D, and this is E and F. F to D is I4. But don't, sir, why you taken this is C, this is C, this, sir, any point is in this wire, any point is C, any point is A, any point is E, because all are joined. But according to this notation only, I give this is E. Every point is E, every point is C, every point is C. Now, to find these currents, I have to know what the voltage. Let this voltage at this node is V1. Voltage at this node is V1. Now apply nodal analysis, find the V1. Apply nodal analysis, find the V1. V1 by 25. V1 by 25. Yes, the current is entering. This current is entering. Minus 0.2 V1. Then V1 by 10 plus V1 by 10. This current is leaving plus 25. This I4 current is also leaving plus V1 by 100. Plus V1 by 100. Can you solve this? What is the V1 you got, friends? Can you solve this? What is V1 you got? If you solve this V1 approximately, you can get 500 volts. Please check it. Are you getting or not? V1 equal to 500 volts. Once you know the V1, this is V1. V1 is plus minus. V1 is plus minus. Okay. Now, how to calculate I1? This I1 equal to I1. Actually, it is a plus minus, but current is flowing like this, away from this one. Actually, the current like this with respect to V1. But this is away from this. That's why I1 equal to minus V1 by, that is minus V1 by 25. Minus 500 by 25. This is equal to minus 20 amperes. I1 equal to how much? Minus 20 amperes. Can you calculate what is I4? This is V1. Every node is V1. This is V1 means this also V1. This is plus minus. Same there. Current is entering at positive like this. That's why this is same. V1 by 100. That is 500 by 100. This is equal to 5 amperes. I4 equal to 5 amperes. Then what is I2, students? Where is I2? Come on, do this. What is I2? See, at this node, this is I1 means at here the I1 current. Apply KCL at this node. I1 is leaving. I2 is also leaving. I1 is also leaving. Sorry, 0.2 V1 is leaving. But this I1 direction is opposite to this one, opposite to this polarity. That's why you have to take like this. I2 equal to minus I1 plus 0.2 V1. 0.2 V1. Minus I1 plus 0.2 V1. This is I2 students. Next. Can you calculate I3? How to get I3? How to get I3? This is I3. This is I3. And this is I4. This is I4. Can I do I3 equal to, this is I3. And this is I4. This total is I4. Not this is I4. Up to this one I4. No? This one is I4. Yeah. This is I4 means this also I4. This is 20. Then what is I3 equal to? I4 plus 25. I4 you already calculated. 5. 5 plus 25. That equal to 30 amperes. Then you calculate I2. You know I1 value. 0.2 V1. V1 also you know. Substitute here. We can get I2. So this is the calculation of I1, I2, I3 and I4. Like this you have to solve. Okay. Problem by seeing this one, it is a very complex network. Then you have to write the equivalent like this. Then you can clearly understand. Yes. This is also previous year question. Can anybody answer this? Determine I. You have to find this current I source. Come on, do it. What is current I? Yes. See, for example, let this point is A, this point is B. This is same wire, no? This is one wire. This is totally one wire source. This is one wire. This is B means this is also B. These two terminals are connected at A and these two terminals are connected at B. Two. This is two similar terminals are connected at A. Two similar terminals are connected at B. Then this combination, series or parallel. See, for example, this is one resistance. This is one resistance. Let this is point A and this is point B. These are connected at A and these are connected at B. Means these two resistances are which ones? Parallel. Like that. Here also, this combination is the parallel combination. Understand? This combination is parallel. This combination is the parallel combination. This is parallel combination. Now tell us friends, how much current is given in this 1 ampere? 1 ampere into 2R. That is what is the voltage drop here? 2R is the voltage drop. Current into resistance is the voltage. Here also what is the voltage drop? 2R is the voltage drop. 2R is the voltage drop. Parallel. Here also what is the voltage drop? 2R is the voltage drop. Understand, sir? Because these are parallel combination. Because already in the problem 1 ampere current is given. This current into this resistance is the drop. This is 2R. This is 2R means this is also 2R because these two are parallel. Now I'm asking the question. If it is a 2R is the voltage drop, what about this current? Voltage is 2R, resistance is 2R, then 2R by 2R. 2R by 2R. But this is the voltage drop. How I calculated this voltage? 1 into 2R equal to 2R. Okay. Then this 1 ampere. This is 1 ampere. This current is 1 ampere. Now tell. This is 1 ampere. What about this current? You tell me. Voltage drop is 2R, resistance is R. That is 2R by R. This is equal to 2 amperes. This is 2 ampere. This is 1 ampere. What about this current? 3 amperes. If it is 3 ampere, this is 1 ampere. What about this current? 4 amperes. If it is a 4 amperes, what is the voltage drop here? 4 into 3R. 12R. 12R. 4 into 3, that equal to 12R. Clear? Come on. Okay. Now I have to find what the voltage across this one. Let this voltage is V. This voltage is V. Now to find this voltage, I'm applying KVL in this loop. To find that, apply the KVL in this loop. KVL. If you apply KVL, friends, positive to negative, negative, minus V. This one. These two are same voltage. Negative to positive, positive. But what the voltage drop here? 2R plus 2R. Next, negative to positive, positive plus 12R. Understand or not? Equal to 0. In this loop, I am applying the KVL. Equal to 0. From this, what is V equal to 14R? Then what is the voltage across? These two are parallel. Voltage across these two are equal to voltage across R. Then what is the voltage across R? 14R. Then voltage across this resistance equal to 14R. I calculated V now. V equal to 14R. Then what the current? I equal to 14R by R. This is equal to 14 amperes. Simple. Just by applying KVL and KCL only we are getting so many answers. I equal to 14 amperes. Clear, friends? Any doubt? This is a 2 marks question in GateX. We got 14 amperes of current. Clear? That you have to check it. Once again, you practice whatever I'm explaining. Any doubt, you please ask me. Then once again, I will explain. This is also gate question. It is a common data question. There is a 2 questions are there. Sorry, there is only 1 question. I will check it. Only 1 question. I think it's a 2 questions are there. Current through 1 ohm resistor is also. Okay, we can check it. Okay. The current IS in amperes in the voltage source and voltage VS in volts across the current source respectively. The current IS in amperes in the voltage source, that is, you have to find IS and VS. And VS, this VS you have to calculate. Yes, come on. How you can do this one? Okay. It's very simple. This current is, how much current is entering here? 2 amperes. Where the current is entering, that is plus, this is minus. 2 into 5, 10 volts. This is 10 volts. Now, this is 10 volts. Apply KVL in this loop, students. Simple answer. Apply KVL. If you apply KVL, positive to negative, negative, minus 10. This one, positive to negative, negative, minus 10. Negative to positive, plus Vs, equal to 0. Then from this, what is Vs equal to 20 volts? Vs I got 20 volts. Simple. Now, this is how much current, students? 2 amperes of current. This is 2 amperes of current. Just tell me. We don't know about this one. This current is 2 amperes because this current only flowing here, 2 amperes. But this is 10 volts means these two are the parallel. This is 10 volts means this is also 10 volts. Then what is this current? 1 ampere. 1 ampere. This current is 1 ampere. This is 2 ampere is entering here. 1 ampere current is flowing here. This remaining is 1 ampere. Then what about this current? This is 10. What is the voltage across 2 ohm resistor? Is also 10 volts because these two are parallel. 10 by 2. That is 5 amperes. This current is how much? 5 amperes. Then apply KCL at this node. If you apply KCL at this node, students, what is the entering current? 1 ampere. Entering currents are taken as a negative, -1. What is the leaving current? +5. What is the leaving current? Is it correct? 20 volts, okay. This 10 by 2, 5. 1 ampere is entering, 5 ampere is leaving. What about IS you have to calculate? Sorry, this is 10, sir, how it is a 1 ampere, sir? 10 by 1, na? Please check it, sir. Calculation. 10 by 1, 10 ampere. Now this is correct. Please check the calculation. 10 by 1, sir. It's a 10 ampere. How you can get a 1 ampere? No? Please check it. This is 10. Now, what is this current, students? 2 ampere is entering, 10 ampere is leaving. This 10 ampere is leaving. At this node, what about this current? This is 2 ampere. This is 10 ampere. This is 8 amperes. Leaving 8 amperes. What about this current? Now apply KCL. Which current is leaving? 8 ampere is leaving. 5 ampere is also leaving. 8 ampere, 5 ampere. IS is also leaving. Apply KCL at this node. IS plus 8 plus 5 equal to 0. What is IS equal to? Minus 13 amperes. Correct. That is IS equal to minus 13 amperes. Voltage is 20 volts. Option D is the correct answer. Clear? Understood or not? Very simple, sir. This 1 ohm parallel na 10 volts, 10 by 1, 10 ampere. 10 ampere is leaving. 2 ampere is entering. 8 ampere must be entering. 8 ampere is this one, 8 ampere. This is 10, this is 2, this is 5 ampere. 5 ampere is leaving. 8 ampere is leaving, 5 ampere is leaving, IS is also leaving. Then sum of the leaving currents equal to 0. Then you take IS plus 8 plus 5 equal to 0, IS equal to minus 13 amperes. Voltage is 20 volts, current is minus 13 amperes. That is option D is the right answer. Clear? Like this you have to follow. Next. In the network shown in figure, if the bridge is balanced, the value of C3 is. If the bridge is balanced, you have to find the what is the value of. Simply remember, students, even measurement subject also you can solve this type of models. Electrical students. Let this is Z1. Let this is, take any impedances. Let this is Z4. Let this is Z2. Let this is Z3. Then I told already at a balanced condition, there is a at a balanced condition. I already given this point in the starting bridge concept at a balanced condition. Let this is the ammeter or galvanometer. That is a Z1, Z4 equal product of opposite impedance. Any notation they give. You take product of opposite. This into this. Z1, Z4 equal to this into this. But no need of derivation. This condition you have to. And one more point to remember. The current through the galvanometer is 0. And one more point to remember. Voltage across adjacent branches is also equal. Voltage across adjacent arms is equal. These are the observations at balance condition. Voltage across adjacent arms is equal. Arms is equal. And this is, for example, this is A and this is B. Then what is VA equal to VB at a balance condition? These are the observations. But to solve this problem, just this condition is enough. In different problems, you have to apply different points to solve this. But in this case, just apply Z1, Z4 equal to Z2, Z3. But don't think always Z1, Z4. Simply remember product of opposite. This into this equal to this into this. Z1, Z4 equal to Z2 into Z3. What is the Z1? 1 kilo. What is the Z4? Z4 is the capacitance. You have to write impedance is 1 by j omega c. Let 1 by j omega c equal to Z2 equal to 3 kilo ohms. 3 kilo ohms. Z3 is capacitance. Capacitance directly don't take. You write impedance 1 by j omega c3. J omega cancels. This kilo cancel. 1 by C4 equal to 3 by C3. Then from this, what is the C3 equal to? 3 into C4. 3 into, what is the C4? 35 picofarads. How much? 3 into 35. How much you get? 105 picofarads. 105. Like this you have to solve. The value of C3 equal to 105 picofarads. Simple problem. But you have to remember at balanced condition, any condition you have to apply. In different problems, you have to apply different ways to solve the problem. You see this one more bridge problem. If the bridge is balanced, the current IS is. You have to find out what the current IS if the bridge is balanced. Students, I told already, if the bridge is balanced, there is no current. You have to neglect this 10 ohm resistance. Remove that one. And if the bridge is balanced, I given one condition. Voltage across adjacent arms is equal. Voltage across adjacent arms is equal. That means voltage across adjacent arms is equal means at balance. To solve this problem, this condition we have to utilize because all our sources are given. You can also apply KVL. By applying KVL also can. I already explained in the bridge concept. That is in top how to apply, in top loop how to apply KVL, in bottom loop how to apply KVL. Like that also you can solve. But simply solve like this. At balance, voltage across adjacent arms is equal. Voltage across adjacent arms is equal. If voltage across adjacent arms is equal, this 9 volts is equal to voltage across 3 kilohms. This positive, negative, 9 volts. These two are adjacent. Then this positive, negative, 2 volts. Now, wherever the positive is there, at that point, current is entering. Wherever the positive is there, at this point, current is entering. Now, if you remove this one, friends, if you remove this, and this current is equal, and this current is, let this current is I1. Let this current is I2. This current is same. This is I2. Now, what is I1 current? 9 by 3 kilo ohms. This is I1 equal to 9 by 3 kilo ohms now. 3 kilo ohms. That is 3 milliamps. What is I2 equal to? 2 by 1 kilo. 2 by 1 kilo. That is 2 milliamps. But why taken direction like this? Because this positive point, this positive potential connected here. Wherever the current is entering, that is the positive. Wherever the current is entering, that is the positive. Now, this is how much? 2 milliamps. This is how much? 3 milliamps. Now, you find this IS. Apply KCL at this node. Entering current is IS minus IS. Entering current is I2 minus I2. Leaving current is I3 equal to 0. From this, what is IS equal to? Minus I2 plus I3. I2 equal to how much? 2 milliamp. I3 equal to how much? 3 milliamp. Sorry, that is I2 or I1? I1, not I3. We take a notation is I1. That is 3 milliamp. Then what is IS, friends? IS equal to 1 milliamp. This is the final answer. Voltage across this arm equal to voltage because of balanced condition. There is proof also there, but mainly the electrical students you studied in the measurement subject. This concept, but not required. Simply remember by KVLs also. How to apply KVL already starting I given. Please go through it. This voltage and this voltage are equal. Then we're getting IS equal to 1 milliamp. Next, with respect to terminals A and B, the network shown in the figure acts as a load resistor of. I told already. If you have to find what is the RAB, if there is no any independent voltage source, if only dependent voltage is present, it is equivalent to dead circuit, or it is equal to passive circuit or impedance circuit. For this type of circuits, how to calculate also I already explained. Can anybody answer this one before writing? Once I complete this, you please try to solve this one. Just I am writing one statement. I already given this one. If network consists of only dependent sources, only dependent sources, network consists of only dependent sources, but no independent source, then that circuit is like a dead network or dead circuit. Dead network behaves like a impedance or resistive passive independent source. Then that network is a dead network or passive network or impedance network. Different names. Impedance network or resistive network. Impedance network or resistive network. Okay. Now, for this case, how to find the equivalent resistance is equal to Thevenin's equivalent resistance. I told her. For this, just we have to connect the one source like this to solve this one. How to connect one voltage source, or based on the circuit given, how to connect either voltage source or current source. This plus minus. This is called voltmeter ammeter method, just like voltmeter ammeter method, because we are measuring we are assuming that 1 volt source, or you have to take one voltage source. Let this current is I. Now apply. What is the observation here? I1 equal to I. I1 equal to I. Apply nodal analysis here. Let nodal analysis. V minus 4I by 4, 4I1 by 4 plus V by 2. The current entering is minus I1 you have to take. V minus I1 equal to I. V minus 4I by 4 plus V by 2 minus I equal to 0. That is V by 4 plus V by 2 minus I equal to 0. V by 4 plus V by 2, you have to get this is 3V by 4 equal to 2I. You find V by I ratio. You bring this I this side. 2 into 4 by 3. That is 8 by 3 volts. V by I ratio is the resistance. Therefore, RAB equal to, how we can calculate RAB? Connect one voltage source. This is deriving the current of, that is V by 3. RAB equal to V by I. This is equal to 8 by 3. If only dependent source is present, like this, you have to calculate effective resistance. It is also called effective resistance or input resistance or Thevenin's equivalent resistance in this case. So, can anybody answer this? This model is, this is a previous question. A nonlinear resistance with V, I relationship, VNL equal to INL square, is the connected across 3 volts source as shown. Determine the power absorbed by the nonlinear resistance. You have to calculate what the power absorbed by the nonlinear resistance. But here don't apply Ohm's law. Why don't apply Ohm's law? Given is nonlinear resistor. Don't apply Ohm's law. Apply Ohm's law. But you have to apply KVL cases. Let this current is INL they given. This is INL means this is also INL. What is voltage? This is 1 ohm resistance. 1 ohm resistance, current into resistance gives the voltage. This INL is the drop. Then apply KVL here. If you apply KVL, friends, what you can get? Positive to negative, negative, minus INL. Positive to negative. This is positive to negative, that is negative. Minus VNL. Negative to positive, plus 3 equal to 0. Minus INL. What is VNL equal to? VNL equal to INL square. Plus 3 equal to 0. From this, we can get a INL square. You can get one quadratic equation. INL square plus INL minus 3 equal to 0. INL square plus INL minus 3 equal to 0. Then you find this, solve this quadratic equation. We can get INL equal to 1.3 amperes. Get INL equal to 1.3 amperes. If INL equal to 1.3 amperes, you have to, what the power? Power delivered by nonlinear resistor, that is VNL into INL. This VNL is nothing but INL square. This INL square into INL. This is equal to INL cube. This is INL cube. That is 1.3 whole square, whole cube. What is 1.3 whole cube squares? Come on to it. This you have to solve this quadratic equation. Check it. Take the positive value. INL equal to 1.3 amperes cycle. Then what is 1.3 whole cube? 1.3 into 1.3 into 1.3. Can anybody? 1.3 into 1.3. So that is 0.69. 0.69 into 1.3. 39,117. That is, we can get approximately 2.2 watt. Is it correct? Is it correct, students? You have to use this relation. VNL equal to INL square. How to apply that relation? Don't apply Ohm's law here. Clear? Next. Yes, friends. Before starting the next model of problem, here I have to explain small concept that you have to concentrate. There is a concept of equipotential nodes. What do you mean by equipotential nodes? This concept is applicable to solve the complex networks questions. By applying this one, we can easily solve that one if any complex circuit is given. That is equipotential nodes. What do you mean by equipotential nodes? Equipotential nodes. Two nodes are said to be equipotential if they are at a same voltage with respect to reference. That is, two nodes are said to be equipotential if they are at a same voltage, if they are at a same voltage with respect to reference, or if they look same from source terminals, if they look same from source terminals, if you see from positive terminal and negative terminal, then those nodes are taken as equipotential nodes. I will give the example also. If they look same from source terminals, from source terminals. Then also equipotential nodes. Then also equipotential nodes. Like then also equipotential nodes. Then we can replace equipotential nodes with open circuit or short circuit. We can get same answer. We can replace equipotential nodes with open circuit or short circuit. With open circuit or short circuit. But you have a doubt here. Sir, open circuit is different, short circuit is different, sir. But why you are replacing with the open circuit or short circuit? See, for example, this is 10 volts. This also 10 volts. You can read 10 volts means no current. No current. If no current means open circuit. Even we can replace this open circuit by this is open circuit. These two nodes is open circuit. But even open circuit is replaced with short circuit also. Why? Because of potential difference, there is no current in this. Even though you connect with wire, there is no problem. Current will not flow. Even though connect with wire, there is no current. Huh? That's why equipotential points you have to replace with open circuit or short circuit. You can replace with open circuit or short circuit. Just join that also, no problem. If the 2 points are same potentials, you can join directly. There is no problem. If the 2 points are same potential. Yes, friends. That's why even though you can replace it with open circuit or short circuit, we can get same answer. If you want proof, I will give the proof. Say for example, let's consider this is the resistance. This is the bridge circuit. And bridge circuit is given like this. Yeah, this is a given bridge circuit. Let this is 1 ohm and this also 1 ohm. 1 ohm. And this is equal to 3 ohms. This is 3 ohms. Let this node is A and this node is B. This is R. Yes. Now this A and B, is it equipotential or not? If you see from positive terminal side, through this path, it offers 1 ohm resistance. Through this path also it offers 1 ohm resistance. And this path, any path you go, it offering the same resistance. Even you check the negative terminal side also. But no need to offer negative terminal side and positive terminal side same resistance. But if you see the negative terminal side, if you go this path to reach the B, it offering 3 ohm resistance. If you go for this path to reach the A, it is offering 3 ohm resistance. But this 1 ohm and 3 ohm not be equal. But this path is 3 ohm, this path is 3 ohm. Yes, this path is 1 ohm. This path same resistance, this path, if you see from positive terminal side, this path is same resistance and this path is same resistance. If you see from negative terminal side, this path is same resistance, this path is same resistance. Then we can say that A and B is at same potential. Therefore, E and B are the equipotential points. Like this, you have to identify. But don't think like this, friends. If you see from positive terminal side, this is offering 1 ohm resistance. But if you see from negative terminal side, it also must be 1 ohm. That is not the condition. If you go for this path is 1 ohm, this path is also 1 ohm. For example, this path is offering 1 ohm. If this path is offering, for example, it is a 2 ohm resistor, then it is not equipotential. Understand? Then this is offering same resistance. And even negative potential side also you can check it. Okay, for example, this side it is satisfied. But in negative terminal side, this is 2 ohms, for example. But A and B is not a equipotential points. Why? This path is offering 3 ohms, but this path is offering 2 ohms. That's why it is not equipotential. A and B is not equipotential. If you see from positive terminal side and negative terminal side, for positive terminal side, for all the path, same resistance. For negative terminal side, for all the path, same resistance is offered. Then A and B is the equipotential points. Now, in this case, it is a equipotential points. So, why we are studying these equipotential points? We have to, once we can identify the equipotential points, that whatever the resistance is there, that you have to make either open circuit or short circuit, we can easily simplify the network. For that reason only, we are defining the equipotential points. Now, see, we know that if A and B is equipotential points, A and B is equipotential points. Equipotential points. Then that points, then A and B is either open circuit or short circuit. For example, I am doing the open circuit. If it is open circuit, what are the equivalence? Say, for example, I am doing the open circuit. If you do the open circuit condition, then this is 1 ohm This is 3 ohms. This is 1 ohm. This is 3 ohms. I'm calculating the between this. Let this is A and this is B. Open circuit. This is open circuit. Let this is X and this point is Y. I'm calculating R equivalent. This is 1 ohm. This is 3 ohms. This is 1 ohm. This is 3 ohms. What is the R X Y strengths? 1 plus 3 4. 4 in parallel with 4 2 ohms. For example, if you take if short circuit, that is A and B terminals are short circuit. This is 1 ohm and this is 3 ohms. This is 3 ohms. And I'm doing the A and B, that is equipotential points are short circuit. And this is 1 ohm and this is the 3 ohms. This is 1 ohm, this is the 3 ohms. And this is XY. Now tell us, this 1 ohm and 1, because of the short circuit, this 1 ohm and 1 ohm is parallel. This 1 ohm and 1 ohm is parallel. This is equal to 1 by 2 ohms. This 3 ohm is parallel. This is equal to 3 by 2. That is 1.5 ohms. Now this is X, this is Y. Then what is RXY? 1 by 2 is 0.5. No? 0.5 plus 1.5. Finally, are you getting same resistance or not? 2 ohms. This is 2. That's why either open circuit or short circuit. Finally, you can get the equivalent resistance is same. That's why equipotential points are either open circuit or short circuit. There is no problem. Yes, friends. Yeah, this is the observation. Now, this concept, how it is useful in gate question. This is the previous gate question. Here, the question is asking, you have to find the what the current. You have to find what the current I is. Right? Can you solve this? What is the current I? First, identify which are the equipotential points. Say, for example, let this is A, this is B, this is C, this is D. First, I'm checking the A and B switch. I'm seeing from positive terminal side. For this path, how much resistance is offered to reach A? 1 ohm. For this path to reach A, B, how much resistance is offered? 1 ohm. Oh, it must satisfy negative terminal side also. See, from negative terminal side. Take any path. See, for example, from this point to reach the B. First, I'm checking A and B. First, I'm checking A and B. To reach the B, how much resistance is offered? Any path must be same. 1 ohm, 1 ohm, 2 ohm. To reach the B, how much resistance it is offered? 1 ohm, 1 ohm. To reach the next. If you check the C and D also, check for C and D also. If you see from negative terminal side, to reach this 1 ohm, to reach this 1 ohm. If you take from positive terminal side, from this path to this path, 2 ohms. From this path to this path, same resistance is offered in both the paths. 2. Then A and B is the equipotential points. C and D is also equipotential points. Therefore, in this network, A and B, C and D is the equipotential points. A and B and C and D is the equipotential points. Therefore, A equal to B and C equal to D. Then if A equal to B and C equal to D, you can open circuit or short circuit. I'm short circuiting this. I'm short circuiting this. This A and this B and this C, this is D. Once you can short circuit, these two resistances are parallel. These two resistances are parallel. Internally, how many resistances? 4 resistances. 4 resistances are parallel. Clear, friends? Internally, 4 resistances also parallel. Then, if these two resistances are parallel, now how much? 1 by 2 ohms. If these two resistances are parallel, 1 by 2 ohm resistance. I'm connecting like this. This is 1 by 2 ohms. And total, in between, how many resistances are there? 4 resistance. 3 ohm, 1 ohm, 1 ohm, 3 ohm. All are parallel. If you want, take it. This is 3 ohm. This is 1 ohm. Again, there is a 1 ohm. Next, it is a 3 ohms. All these are the parallel. Network becomes very easy. This is 1 by 2 ohms. Then how much source is connected? 11 volts. 11 volt source is connected. This is current you have to calculate. Can you do the calculation? Come on, do it. This 3 ohm parallel. That is a 1.5. 1 ohm parallel. 0.5. 3.5 into 0.5 by this is how much you can get. You do the calculation, tell the answer. Come on. What are equal? Actually, the 1 by 3 plus 1 by 3, 2 by 3, 2 by 3 plus 2. that is say 2 by 3, 8 by 3 we can. Then we can get R equivalent equal to 1 by 2 plus this total is 8 by 3 you can. If you want to do that, 8 by 3 plus 1 by 3. Then what is the R equivalent equal to? 1 plus 8 by 3. This is equal to 11 by 3. Then what is the current I equal to? V by R equivalent. What is V, students? 11 by 3. So V is 11 volts. What is R equivalent? 11 by 3. 11 by 3 R. Is it 11 by 3? It's not 8 by 3. I think it's a 3 by 8 we can get. Not 8. Please correct it. 3 by 8. Please do the calculation, sir. Calculation is in our hand. This is equal to 11 by 8. 11 by 8, that is 11 by 11 by 8. We get 8 amperes. This is the 2 marks question in details. That is this type of problems, complex circuits. The only by defining the equipotentials, we can easily solve the question. That's all. Sir, I don't want to solve with the equipotential, sir. Is there any other method? Is there no other alternative? You go first delta to star conversion. You convert delta to star. You convert delta to star. Then you solve. That is one method. Sir. If you are not defining this one, whatever the delta connection is there, you convert into star. Then you have to simplify. Starting, I will be given 1 or 2 problems how to convert also. Please go to that. It's 11 by 8 amperes. If you are not getting idea about equipotential points, then go through the delta to star conversions. Then we can easily solve it. Next. And one more problem that I have to solve here. For example, students, 1 ohm resistance or 1 ohm resistors are connected as edges to form Q. Find R equivalent between any two diagonally opposite corners of the cube. Diagonally opposite corners of the cube. Opposite corners of the cube. Yes. If this model is given, there is a 3 conditions are there here. Only for one condition I am giving the proof. Remaining condition directly I am giving the answer. 1 ohm resistors are connected as edges to form Q. Find R equivalent between any two diagonally opposite corners. See, for example, this is the Q. It's a given Q. The cube is given like this. Let all are equal resistances. All are 1 ohm resistance. This all are 1 ohm resistances. Now, let this source is connected like this. But here it is asking that any two diagonally opposite corners. This is diagonal, but opposite sides. This is one side and this is another side. This is one side, this is another side, opposite diagonal. Then between this you connect the source. Wherever it is asking, between that only you can connect the source. Here 3 conditions are there, but first model only I am giving the proof. Here I am connecting the source. Let this current is I. Yes. Let this nodes I am taking. This is A, and this is B, A, B, and now take or otherwise you take this is nodes. I'm taking different color. Take this is A, this is B, and this is C, this is D, this is E, this is F. Take this is G, and this is the H. It's H. Yes. Yes. Just a minute. Oh, now let this why I'm connecting sources between these two terminals only. The question is asking any two diagonally opposite corners of the cube. Diagonally opposite corners. Opposite corners. Opposite side corners. This is one side, this is another side. This is diagonal. Now you check it. Here there is a 3. Here also resistance now. Here also resistance. Resistance. Now here the current is divided. But point to remember, this current division not only depends only on this resistance. All are equal resistance. All are equal resistance. See, this current division, don't think only this resistance. From A to B, how much this A to B? This one, see. You take from any from point A to G, because terminal A and terminal B, now, you take this one. A to G, you take any path. How many resistance? 3 resistance. Here, how many resistance? 3 resistance. From A to G, how many resistance? 3 resistance. You take any path from A to G, 3 resistances are offering. Don't think it is depending only on these resistances. Because this resistance is connected to this one. This is connected to this one. This resistance is connected to this one. This resistance is connected to this one. Students can think like this. This current division depends only on R only. That's why I by 3, I by 3. Not. The same resistance is offering from A to G. Same resistance is offering from A to G. Same resistance is offering from A to G. That's why I'm taking this. This is I by 3. Equal current. Because of same resistance is offering now. Current is equally divided. But here equally divided not only because of R. This also depends on the total resistance offered from A to G. From this terminal to this terminal, sir, how much resistance is offering for that current? All the paths, same resistance is offering now. That's why I taken equal current. This is I by 3, I by 3, I by 3. Clear, friends? Now here current is entering is I by 3. Here the current entering is I by 3. Here the current entering is I by 3. Okay. Now see, from this node to this node, finally you want to reach to G. Finally you want to reach to G now. A to G we are defined. You take from this point, same resistance. Take from this point, same resistance is on. That's why current is equally divided. 2 paths now, that's why I by 6. 2 paths now, that's why I by 6. 3 paths I by 3. 2 paths I by 6 by 2. Next. This is I by 6. This is I by 6. Okay. This is I by 6. Now here also resistance is there. Here also resistance. If I get this. Connect here also resistance. Okay. Here also current is divided. This is I by 6. 2 paths I by 6. From that point to final point is offering same resistance I by 6. Now this is I by 6. Here also resistance is there. You connect in every branch, connect the resistance. This is I by 3. Here current is divided. This is I by 6. This also I by 6. Because of 2 paths. Now current entering is I by 6. This is I by 6. This is I by 6. Total is I by 3. This is I by 6. This I by 6, I by 6, I by 3. Now what are the current enter here? I by 3. What are the current enter here? I by 3. This is I by 6 now. What are the current? This path is also I by 6. I by 6, I by 6, I by 3. Now what are the currents entering at this node? Current leaving the node is I by 3, I by 3, I by 3. Current entering the node is I by 3, I by 3, I by 3. I by 3 plus I by 3 plus I. Total I. Therefore entering current equal to leaving current. KCL is satisfied. Take any loop, then apply the KVL. Take any loop. Simply I am applying the outer loop. Apply KVL in this loop. Easily you can. This is a simple method to solve this one. KVL. If you apply KVL, current is entering plus minus. Current entering plus minus. Current entering plus minus. Then minus I by 3 into R. Next. Minus I by 6 into R. Minus I by 3 into R. Negative to positive, positive. Plus V equal to 0. This I by 3, this V equal to I by 3 into R plus I by 3 into R plus I by 6 into R. I bring this I is common, then V by I equal to R by 3 plus R by 3 plus R by 6. Then V by I equal to R by 3, R by 3, 2R by 3 plus R by 6. 6 is LCM, the 5R by 6. That is R, V by is R equivalent. Then R equivalent equal to V by, this is equal to 5 by 6 into R. This is the resistance between in a cube, but diagonally opposite corners. Diagonally opposite, two diagonally opposite corners of the cube. Opposite corners of the cube. 5 by 6. But this problem not only resistance, they will give the inductance, they will give the capacitance, they will give the conductance. Same method only how to follow. But point to remember, friends, note I am giving. Therefore, diagonally opposite corners of the cube. Diagonally opposite corners of the cube. Corners of the cube. Diagonally opposite corners of the cube. Corners of the cube. R equivalent equal to 5 by 6 into R. This results directly. L equivalent equal to same 5 by 6 into L if inductances are given. C equal, if capacitance is given, exactly reverse. 6 by 5 into C. If capacitances are given, you have to take the 6 by 5 into 6 capacitances. Because the impedance is inversely proportional. I told so many times. The impedances are inversely proportional. Then you have to take the, that's why instead of 5 by 6, you have to take the 6 by 5. If conductance is also given, conductance and resistance is inversely proportional. Conductance and resistance is inversely proportional. If conductances are given, you have to take the conductance equal to G equivalent equal to 6 by 5 into G. Okay, these results you have to remember. But same problem we can also solve by using equipotential concept. Same problem we can also solve by using equipotential concepts. Same problem we can also solve by using equipotential concept. In this case, which are the equipotential points? You have to check it up. Which are the equipotential points? That is same problem. You see this one? You can also using equipotential points. Using equipotential points. Same problem we can also solve. Equipotential points. If it is asked equipotential points, which are the equipotentials here? You see the BED is the equipotential points. From positive terminal, you check for BED points. From negative terminal, you check the path for BED. You can get the same distance. That's why that I am leaving for you in this B equal to E equal to D. If you want to check the path, I am leaving for you. That is equipotential points. Equipotential points. And one more is F equal to C equal to H. F equal to C equal to H. That is equipotential points. Take from positive terminal side. How to check I already explained. That I am leaving for you. Equipotential points. Equipotential points. F equal to C equal to H is also equipotential. Then we can join the equipotential points now. BCD is joined like this. FCH is joined. If BCD joined, FCH is joined. This one, these resistances. Here also resistances are there. Here also resistance is there. Here also resistance is there. See. If it is joined, this resistance and this resistance, these three resistances are parallel. This side, these three resistances are parallel. Remaining internally, how many resistance? 1, 2, 3, 4, 5, 6. Internally, 6 resistance is also parallel. Understand, sir? Because BED is equipotential point. FCH is also equipotential points. Then if you draw the equivalent, you can check the path that I'm leaving for you. Just okay. Okay. Here itself, I'm sorry. If you join, if you draw that one equivalent, these three resistances are parallel like this. 1, 2, 3. In between, how many resistances are there? 1, 2, 3, 4, 5, 6. Is it correct? Is it 6 resistances? Yes, 6 resistances parallel. 1, 2, 3, 4, 5, 6. All are equal resistance. Next 3 resistances. 1, 2, 3. This is between A and G. Now, what is R equivalent? This is R by 3. This is R by 16. This is R by 3. That is 2R by 3 plus R by 6. 6 is LCM. 5 by 6 into R. We are getting same answer. We are getting same answer or not? This is one more method. Actually, whatever the first method is there, this method is applicable only for this case. But this method is applicable, equipotential case is applicable for any case, not only for opposite corners. You find what is the equivalent resistance between A and B. You find what is the equivalent between A and C. A and C. For that, I'm not giving proof directly because that question is not that much. But mostly, only this model only repeated in all the competitions. If that is asked directly, you can answer. If you want to, you try for using that is equipotential method. You try for that problem. Clear? That you have to concentrate. You can apply equipotential concept, or you can apply the KVL for this case. This I'm giving only note point. For example, this I'm erasing this. In this circuit, if it is asked in this circuit, if it is asked what is the RAB between A and B, it is asked RAB. Then R equivalent equal to 7 by 12 ohms. We can RAB you can get 7 by 12 ohms. By derivation we can get questions, but not required that much of derivation. All this simply this is equal to 7 by 12 ohms we can get. Even L equivalent equal to 7 by 2. What is C equivalent? 12 by 7. This is one result. But up to now, in previous computer exam, only this model is free. Only this result is asked, but this result is not asked. But you have to remember. If it is asked, same side diagonal, same side. This is, I'm asking this one. Then you connect source here. Apply the equipotential concept. If it is asked like this, RAC, same side diagonal, not opposite sides. This is one side now. This is one side. This ABCD is one side. EFGH is opposite side. But same side diagonal. RAC is asked. Between A and C it is asked. Apply the equipotential method. Try to solve that one. Then we can get a RAC equal to approximately 3 by 4. Even in this case, L equivalent is also Henry. Don't confuse. This is farad. This is farad. On the same, this L equivalent is Henry. This is conductance. Even Z equivalent here. Z equivalent is same equal to R equal 5 by 6 into R. 5 by R into Z. Even impedances are given similar to resistance. Only capacitance only in conductance is different. L equivalent is this is 3 by 4 into R. This is 7 by 12 into R. Instead of writing that, directly I'm writing. This is 7 by 12 into R. L by 7 by 12 into L. 12 by 7 into C. This is in farad. This is in Henry. This is ohm. This 3 by 4 into L. C equivalent equal to 4 by 3 into C. 4 by 3. Only capacitance is reverse. 4 by 3 into 6. That part. Capacitance and the conductance. Conductance no need to, you know already. But capacitance is also inversely proportional impedance. 4 by 3 into C. Even Z equivalent equal to 3 by 4 into Z. Then if it is asked, G equivalent equal to 4 by 3 into G. 4 by 3 into here also. Z equivalent equal to 7 by 12 into Z. G equivalent equal to, in this case, 12 by 7 into G. Friends, these are the different models of questions with respect to fundamentals of electrical circuits. In Telegram channel, some practice questions I will share. You please practice that questions. That models are enough for any exam point. You try this question based on the capacitance. If you have any doubt, you please share your doubt. For same question, this is the common data question. This is a previous gate question. This is also previous gate question for capacitance calculation. Please share your doubts in my Telegram channel. Yeah, this is about the concept of fundamentals of electrical circuits. In the next session, maximum I'll try to start the chapter 2. If time is there, I will take some practice questions in the fundamentals itself. But first we have to finish the next concept. Chapter 2, AC analysis I will start. AC analysis fundamentals, resonance, coupled circuits will be covered in the chapter. And after that, we go for the theorems and transitions. Yes, friends, this is about the today's session. Any doubt? Okay, thank you. Please collect this PPT in my Telegram channel. I think who don't know about Telegram channel, I already given. Second, I'm writing. Please join Smart Gate Rankers. All are small letters. If any new students are there, please join us and collect this PPT. And with respect to fundamentals, I will share some practice questions. You please practice. Thank you. This is about today's session.